Have you ever wondered how solar energy reaches Earth and influences our climate? Well, it begins a whopping 93 million miles away, where the sun, a colossal ball of hot glowing gases, emits a constant stream of energy. This energy, bundled into tiny particles of light called photons, embarks on an 8-minute journey through the vast expanse of space, finally arriving at Earth in the form of solar radiation. Now, this solar radiation is a cocktail of different types of energy. Visible light that illuminates our world, ultraviolet light that gives us a tan, and infrared energy that we feel as heat. And it's this sun's energy, this solar radiation, that is the heartbeat of life on Earth. It powers photosynthesis in plants, drives the weather and climate, and even fuels our own human endeavors through renewable solar power. So, the sun sends its energy to us in the form of solar radiation, but what happens when it reaches our planet? You might be surprised to learn that not all the solar energy that reaches Earth's atmosphere makes it to the surface. As solar radiation enters our atmosphere, it encounters clouds and particles, some of which reflect this energy straight back into space. This is the first interaction of solar energy with our atmosphere, but that's not the only interaction. Some of this solar radiation is absorbed by the atmosphere itself, heating it up. So what happens to the rest of the solar radiation? Well, it continues its journey, reaching the Earth's surface where it is absorbed by the land and oceans. This absorption further heats our planet, contributing to the overall warming we experience. But remember, the energy doesn't just stay here. It undergoes transformations, driving processes like evaporation, photosynthesis, and weather patterns. So, the solar energy that reaches Earth doesn't just stay here. It gets used and transformed, playing a critical role in our climate. Now that we know how solar energy reaches and interacts with Earth, what does it mean for our climate? Well, let's delve into the concept of radiative balance. This is the delicate equilibrium between the incoming solar radiation, the light and heat that our sun showers upon us, and the outgoing thermal radiation that Earth emits back into space. It's a bit like a cosmic game of catch, with Earth and the sun tossing energy back and forth. When the sun hurls a ball of solar radiation our way, Earth's atmosphere and surface absorb some of it, causing them to heat up. But this heating isn't uniform. It varies based on the angle of the incoming solar radiation, the composition of the atmosphere, and the characteristics of Earth's surface. Picture a patchwork quilt of warm and cool spots, each patch with its own unique blend of conditions. And here's where things get really interesting. This uneven heating sets the stage for wind and ocean currents, essentially powering Earth's climate system. It's like the solar energy is the conductor of a grand symphony, with each note a gust of wind or a ripple in the ocean, all coming together to create the weather patterns and climates we experience. So, solar energy not only lights and warms our world, but it also drives the complex systems that dictate our weather and climate. But what happens when the amount of solar energy reaching Earth changes? You see, solar radiation isn't always constant. It ebbs and flows in a rhythm known as the solar cycle. This cycle, which lasts approximately 11 years, sees solar activity wax and wane, resulting in variations in the amount of solar radiation that reaches our planet. Then there are solar flares, spectacular explosions on the sun's surface that hurl intense bursts of radiation into space. When Earth is in the path of this radiation, we can experience changes in our upper atmosphere, which can have ripple effects on our weather patterns. These variations in solar radiation can influence Earth's climate over long time scales, causing periods of warming and cooling. But here's the key point. While these solar variations can have significant effects, they are not the primary drivers of the current trend in global warming. That's right. Despite the sun's powerful influence on our climate, it's human activities like burning fossil fuels and deforestation that are largely responsible for the rapid rise in global temperatures we're seeing today. These activities are increasing the concentration of greenhouse gases in our atmosphere, trapping more heat and disrupting the delicate balance of our climate system. So, while the sun's energy drives our climate, it's the actions here on Earth that are causing the most significant changes to our climate today.